So what is recursion in Python? Recursion is an essential concept. It's a skill that, once mastered, can solve problems in ways that loops simply can't. If you skip out on recursion, you're missing out on the full power of Python. So if you're serious about getting better at your coding skills, watch this video till the end. So what exactly is recursion? Let's start with a simple definition. Recursion happens when a function calls itself in order to solve a problem. Instead of solving the entire problem at once, recursion breaks it down into smaller, manageable pieces. It's a bit like Russian dolls, where you open one only to find another one inside, and so on. Eventually, you hit the smallest doll, and that's when you're done. But to make sure this doesn't go on forever, recursion relies on two important concepts: the base case and the recursive case. The base case is the condition that stops the recursion. Without this, your function will keep calling itself infinitely. And the recursive case is where the function keeps calling itself with the smaller or simpler problem. So let's see an example. We're going to start with a classic example of calculating the factorial of a number using recursion. So the factorial formula looks something like this. The n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 up to 1. So for the 5 factorial, this formula will look something like this. Here we have 5 multiplied by 4 multiplied by 3 multiplied by 2, and finally multiplied by 1, which will give an output of 120, which is the factorial of 5. Now we can also define the same formula recursively as n factorial is equal to n multiplied by n minus 1 factorial. So the 5 factorial can now be written as 5 multiplied by 4 factorial, and then this 4 factorial can be written as 4 multiplied by 3 factorial, and 3 factorial can be written as 3 multiplied by 2 factorial, and finally, the 2 factorial can be written as 2 multiplied by 1. So if we multiply all the numbers, then we get the same result. So if you remembered, we just talked about something called the base case. So when we are dealing with the factorial problem, then the 1 factorial is our base case. This is the point in our program. When our program reaches to this point, the recursion stops. Okay, so now let's implement all these concepts into Python code. Here we're defining a function called factorial, and it takes one parameter, n. This n is the number we want to calculate the factorial for. So if we pass n equal to 5, the function is going to compute the 5 factorial. And then we will use the if-else statement. So if n equal 1, we will return 1. Now this is crucial. These two lines represent what we call the base case. This is the condition that tells our function when to stop. Without a base case, our recursion would go on forever and crash the program. The condition if n equal 1 checks if n has become 1. Why 1? Because the factorial of 1 is just 1. No further calculations are needed. So if n equals 1, the function returns 1. This return value stops the recursion from continuing, which will result in breaking the cycle. And then we write our else statement, which will return the multiplication of n and the factorial of n minus 1. Now here's where the recursion kicks in. If n is not equal to 1, we move to this else block. In this line, the function is returning n multiplied by factorial n minus 1. So let's say n is 5 in this case. So what we are doing is that we're multiplying the 5 by the factorial of 4. So this line of code is simply saying that, hey, I don't know what the 5 factorial is right now, but I do know that it's 5 times whatever the 4 factorial is. So let's call the factorial 4 and figure it out. This process repeats over and over until the function reaches the base case where n is equal to 1. And then finally, we will print the value of factorial 5. So now let's track all the recursive calls that happen behind the scenes when we run the program. When we call factorial 5, this is what happens behind the scenes. So on calling factorial 5, the function says 5 is not equal to 1, so return 5 multiplied by factorial 4. In our second call, we are calling the factorial 4. So again, the function says 4 is not equal to 1, so return 4 multiplied by factorial 3. Then in our third call, we're calling for the factorial 3. And again, 3 is not equal to 1, so it returns 3 multiplied by factorial 2. Then in our fourth call, we're calling for the factorial 2. And again, 2 is not equal to 1, so it returns 2 multiplied by factorial 1. And now in our fifth call, we're calling for the factorial 1. So now we hit the base case, as the function sees n equal 1 and returns 1. So no more recursive calls. So once we hit the base case, we start unwinding the stack to function calls, multiplying the results together. So factorial 2 becomes 2 multiplied by 1, which is equal to 2. Factorial 3 becomes 3 multiplied by 2, which is equal to 6. Factorial 4 becomes 4 multiplied by 6, which is equal to 24. And finally, factorial 5 becomes 5 multiplied by 24, which is 120. And just like that, the function returns 120, which is the factorial of 5. Now you can see how recursion can make your problem simpler by breaking it into simpler tasks. So now you might be wondering, if recursion is so great, why don't we use it for everything? Well, recursion is incredibly powerful, but it's not always the best solution. So when to use recursion? Use recursion when a problem can naturally be divided into smaller problems, like divide and conquer algorithms or problems like factorials and Fibonacci. And when not to use recursion? Recursion can be less efficient than loops because every recursive call adds a new frame to the call stack. If you're dealing with deep recursions, this can lead to a stack overflow error. Also, recursion can sometimes be harder to read and debug for more complex problems. But don't worry, we'll cover more advanced recursion topics like tail recursion and how to avoid stack overflows in a future video. So make sure you're subscribed with notifications on. You don't want to miss that. Alright, that's recursion. You now know how recursion works, how to implement it, and when to use it. If you found this video helpful, don't forget to hit the like button and drop a comment below if there's anything you'd like me to cover next. Thanks for watching, and I'll see you in the next video.